Okay, so question 9. If I want to know y-intercepts, the thing that I have to know to be able to do that is to plug in 0 for x and solve. So you get 0 minus 0 over 0 minus 0 minus 3, and 0 divided by negative 3 is 0. Now, technically the origin's not just a y-intercept, it's also an x-intercept. So I know that's going to be over there as well. For these three, we need to know which numbers make the numerator 0 and denominator 0. So that implies that we need to factor. So anytime you've got a GCF, you should factor it out. And then once it's factored, it's a lot easier to see where this equals 0, where this equals 0, where this equals 0, and where that equals 0. And if there's any number in both lists, any number that makes the numerator and denominator 0, that's how you get a whole. Any number that just makes the numerator 0, that's how you get x-intercepts. And any number that makes just the denominator 0 gives you vertical asymptotes. So other than factoring, I'm not really doing much work. Sounds like I am because I'm verbalizing all the directions here, but once you really know those three rules, it's not much work other than factoring, and you don't need to factor on every question. Okay, for domain, domain is a way to describe the x values that you can plug in. So you can plug in basically anything you want to, but you can't plug anything in that gives you division by 0. So we need to make sure that we skip -1 and that we skip 3. So the numbers we can plug in would be everything to the left of -1, everything between -1 and 3, and everything bigger than 3. So again, I suggest that you make this little number line because it helps you visualize the parts of your domain. But after you do that for a while, you don't have to do the number line for me. I just think it helps you. Okay, horizontal asymptotes, the rule where we have to compare the degree of the numerator to the degree of the denominator. If the degree of the numerator is bigger, we don't have a horizontal asymptote. If the degree of the denominator is bigger, it's y equals 0. And if the degrees are equal, like they are here, it will be leading coefficient 3 over leading coefficient 1. So y equals 3. And finally, the last piece of information that we have to have memorized so we can use it is for slant asymptote. In slant asymptote, we would long divide these two, and it would be y equals whatever the quotient is, ignore any remainder, but only if the degree of the numerator is 1 bigger than the degree of the denominator, which doesn't happen here, so luckily we get to skip that on this one. Okay, if we start throwing this stuff on the graph, our y-intercept, our x-intercepts, can't graph a hole if there's not one, all of our asymptotes need to be shown as dashed lines, whether they're vertical lines or horizontal lines or slants. And as soon as you do that, most of your graph is now finished. Now, more points is always better. Last class we saw anywhere from 2 more points were needed to no more points were needed. Just kind of depends on the function. So right now, really the only thing that I know for sure is I know how it behaves around horizontal asymptotes and vertical asymptotes. Horizontal asymptotes only tell you what's happening at the ends of the graph. So if I'm sure about this point and I'm sure about my horizontal asymptote, I know that this guy has to approach it on the far right. And since I know vertical asymptotes are going to be a spike in the graph, if this guy is going down on the right side, he's going to continue to go down. And if he's spiking down on the right side, he's spiking up on the left side. Then we've got this point, so I anticipate that this should go to this point. And then based on this direction, he's going to negative infinity, which means the other side's going to positive infinity. And then finally, the end of the graph, this has to approach the horizontal asymptote again. Yes?
Can you show how you figured out the middle one again?
Well, I knew it had,
I know that's the shape of it.
I knew it, are you okay with why it has to be up here?
No.
Okay, so over here, this side's going down, so that's how I know this side has to go up. Are you okay with why I know this side's going down?
I think so.
Okay. So, this type of question often throws people off a little bit because of this. This is a big misconception. You can cross a horizontal asymptote or a slant asymptote. If your graph has 3 sections, it's completely fair game to cross in the middle. It doesn't have to. Sometimes it doesn't. I think question 1 is pretty similar where it didn't. But this one does. All the horizontal and slant asymptote tells you is this: what's happening at the end of the graph. Anything in the middle of the graph is still fair game. You can cross a horizontal asymptote. But again, if you feel kind of shaky in the middle here, you're not real confident about this, then what you should do is say, okay, let me get some more points. Let me plug in x equals 1, and then hopefully it's right around here. Because if it's not around here, then I did something wrong. So plug 1 into the function. You get -9 in the numerator. -4 in the denominator, so 9/4, which is a little bit bigger than 2. Bless you. So now my graph's just a hair more accurate, but it confirms what I was expecting to happen. Likewise, if you're not sure why this is up here, maybe you thought it was down here or something, feel free to plug in x equals -2 or -3 or -4. Find the y value, and then you'll see that y is up here, not down here. So if you're ever unsure if you have enough points, then that means you need more points. There's nothing wrong with getting more points.